This should be revision. Pause the video and have a go at these. So hopefully you've remembered the rule that if you are multiplying powers of the same base, then to get the answer you can just add the powers. Note that the base is the number that you're doing to the power of something, and the proper name for the power is an index, and the plural of index is indices. Check that you got these answers correct. Again, pause the video, have a go at these. So this is one of the other rules that you need to learn, that if you're dividing powers of the same base, you subtract the powers. Check that you got the answers correct for these. So here's some questions using those rules of indices. Pause the video. Hopefully you got these using the different rules involved for each one. Your final answer should be the value of the letter in each case. What do you think? Well, 2 cubed would be 2 times 2 times 2, and 5 to the power of 4 would be 5 times itself, 4 times, and they've said that the answer is 10 to the power of 7. Well, it doesn't look like it. I guess we could spot 2 times 2 times 2 would be 8, 5 times 5 times 5 times 5. Well, maybe a bit big to do that calculation. An easier way of looking at this would be to say we could pair up these values. So 2 times 5 would be 10, another 2 times 5 would be another 10, and then we've got 2 times 5 times 5, so that's times 2 times 25. So that's going to give us 50 times 10 times 10, 50, 100 or 5,000, which is not the same as 10 to the power of 7. Read through this, check you remember this rule, pause the video and have a go. Now that one should have been really straightforward. Anything to the power of 0 is just 1. The only answer here that wasn't 1 was this final one. 2 cubed would be 8 multiplied by 2 to the power of 0, which is 1, giving us a final answer of 8. Pause the video and have a go at these. So we've got this idea that a negative power makes a reciprocal, so 1 over. So 3 to the minus 2 means 1 over 3 squared, which is 1 over 9. 3 times minus 2, this is just an ordinary multiplication, we get minus 6. 3 to the power of 0, anything to the power of 0 is 1. 3 squared, just straightforward, 3 squared is 9. 3 to the minus 3, the minus tells us it's 1 over, and then 3 cubed, 3 times 3 is 9, times another 3 is 27, so that will be 1 over 27. 0 cubed, well 0 times 0 times 0, in fact 0 times anything, just gives us 0. And finally, minus 3 cubed. Using BIDMAS, we do the power before we do the multiplying. So 3 cubed is 27, times minus 1 makes minus 27. Here are some more questions. Have a go at these, pause the video. Okay, so 5 to the power of 0, or anything to the power of 0, is 1. 4 to the minus 1 doesn't mean minus 4. The negative power means 1 over, so it should be 1/4. 4 times 8 to the power of minus 1. Well, that's 4 times, and then the minus 1 gives a reciprocal, 1 over, so that's 4 times 1/8, which is 4, you could think of it as 4 over 1, times 1 over 8, 4 over 8, which would be a half. Now 6 cubed times 6, I'm not sure how they've got equals 6 there, any number just on its own, we could write that as 6 to the power of 1. So 6 cubed times 6 to the power of 1, if we add the powers, we would get 6 to the power of 4. Here we've got one which does involve a reciprocal, but this is going to mean 3 times, now 2 to the minus 1 is 1 over 2, so we'd end up with 3 over 2 or 1.5. The 3 is not in the denominator because the minus 1 only applies to the 2. Here's another one. We've got rules of indices here, so what we're going to do is add the powers. So we've got 3 add minus 2. Now 3 add minus 2 is the same as 3 minus 2, which is just 1, so we end up with 2 to the power of 1, also known as 2. Here's one, we've got the same base, 8 to the 9 divided by 8 cubed. We subtract the powers, so 9 minus 3 is 6, so the power is correct, but the base is 8. It should be 8 to the power of 6, not 1 to the power of 6. And finally, 6 to the minus 2. The minus tells us reciprocal, but it's not 6 times 2, it's 6 squared. So it should be 1 over 36. Pause the video, have a go at these. Okay, so this is the rule where if you have something in brackets to a power, also known as a power of a power, you multiply the indices. You can see from the example, 2 to the power of 5 cubed means 2 to the power of 5 times itself 3 times, and then that means you would be adding up the 5 3 times, also known as 3 times 5. So the answers to the remaining questions are here. Pause the video, have a go at these. So some of these were slightly harder. You do need to use your bid mass a bit, in particular on questions like this one, where you would do this first, so 4 to the power of 15 times 4 to the power of b. That means that the 15 plus the b would give us the power in the answer, which is 27, leaving us with b is 12. Here's a place where you have to be careful with the brackets. Let's see what this means. 2c to the power of 5 means 2c to the power of 5, and then we're going to cube it. So we're going to times it by itself 3 times. Now what you'll notice there is we've got 2 times 2 times 2. So the cube has applied to the 2, so we have got 2 cubed, and then we've got c to the 5 times c to the 5 times c to the 5, which is c to the 5 cubed. So we can think of it as applying this cubed power to both of the terms in the brackets. So 2 cubed is 8, so it's definitely not one of these answers. And then c to the power of 5 cubed, we're going to multiply those to get 15. So the correct answer there was 8c to the power of 15. So this is a slightly different way of asking a question. They want everything written as a power of 2. For example, let's say you were asked to write something as a power of 3, and perhaps you might be given 1 over 81. Now you might know that 3 to the power of 4 is 81, and we want the reciprocal of that, so the answer would be that we would write 1 over 81 as 3 to the power of minus 4. Have a go at these questions, pause the video. Okay, so 4 is easy enough, hopefully. 2 squared. Now 4 cubed, well 4 is 2 squared. So we've got, this is the 4, and then we're going to cube it. And then using rules of indices, we multiply 2 by 3 to get 6, so it would be 2 to the power of 6. Similar thing for this one, but we would use 2 cubed to make the 8, and then that's to the power of 5, so 3 times 5 is 15, we end up with 2 to the power of 15. Here we've got 8 to the power of minus 1, now 8 is 2 cubed, so we want 2 cubed to the minus 1, 2 to the power of 3 times minus 1, 2 to the power of minus 3. Here 16, 2 to the power of 4, hopefully you learnt that one last week, and then that is to the power of minus 2. We multiply the powers, 2 to the minus 8. This one's slightly longer, so we've got 4, which is 2 squared, and then that's squared, multiplied by 8, which is 2 cubed, and then the 8 is to the power of minus 2. So it'd be sensible to take a couple of steps. This is 2 times 2 is 4, so we've got 2 to the power of 4. And then here, 3 times minus 2 is minus 6, so 2 to the minus 6. And then finally, because we're multiplying powers of the same base, we add the powers. So 4 add minus 6 is minus 2. And finally, 3 to the power of 0 is equal to 1, but we need to write that as a power of 2. Well, anything to the power of 0 is 1, so it's... Here we start looking at fractional powers. So first of all, the power of a half. If you add the powers, you'll get the power in the answer. So 9 to the power of a half times 9 to the power of a half gives 9 to the power of 1. But what number times itself makes 9? Well, 3 times itself makes 9. 3 is the square root, that's why it works. So the power of a half means the same as the square root. In a similar way, power of a third will be the cube root, and so on. Pause the video and have a go at these questions. So hopefully these weren't too tricky. This one here, 64 to the power of minus a third, the minus tells us the reciprocal, so 1 over. So it's 1 over the cube root of 64, which is a quarter. And finally, quarter root will be the fourth root. So 2 to the power of 4 makes 16, so 16 to the power of a quarter makes 2. These ones look a bit daunting when you first look at them. What the idea is here, we've got 16 to the power of 3 quarters. Now you could say that 3 quarters is 1 quarter times 3, or 3 times 1 quarter. Now when you're doing these, you can do the powers and roots in either order. So you could do 16 to the power of a quarter, so take the fourth root of 16, which is 2, and then cube it. 2 cubed is 8. Or you could do the 16 cubed first, and then take the fourth root. Now 16 cubed, bit more of a faff to work out, but it will work. You would get 4096, and then the fourth root, you'd probably have to do prime factorisation to work this out, would be 8. I'm guessing most of you prefer this one. In general, it's easier to take the root first, so that you're dealing with smaller numbers, and then take the power. Have a go at these questions. So here are the answers for this first row. Just to go through a few of them. 81 to the power of 3 over 2. We could do 81 cubed, but that's going to be a big number. It's much easier to do the square root first. So the square root of 81 is 9, and then cube it, and 9 cubed is 729. If we look at one like this one here, 125 to the minus 2/3, the minus tells us it's a reciprocal, so 1 over the cube root of 125 squared. So the cube root of 125 is 5, and we're squaring it, and then it's 1 over that because of the minus sign. You might see these written as a decimal. What you need to do in that case is rewrite it as a fraction. So 0.8, that's 8/10, which simplifies to 4/5. So 32 to the power of 4/5, take the fifth root first, which is 2, and then 2 to the power of 4 to get 16. The ones on this second row are similar. The power applies to the numerator and the denominator. So in both cases here we would cube root and then square it. So cube root of 64 is 4, cube root of 125 is 5, and square that to get 16 over 25. Now if you had something with a negative power, 1 divided by a fraction is going to end up reciprocating the fraction. So dividing by 16 over 25 is like multiplying by 25 over 16. You'll see in the same way, whenever you have something with a fraction and a negative power, you reciprocate the fraction. So instead of 16 over 25, if you reciprocate that to make 25 over 16. And then 1.5, if we write that as a fraction, it's 3 over 2. So the 2 means that we square root and the 3 means that we cube it. So the final answer would end up being 125 over 64. That's as complicated as these questions will get, where you have a negative power, which is a fraction, and the number you're doing it to, the base, is also a fraction. Here are some slightly more challenging questions to have a go at. Pause the video. So this 16, we want the 4th root, which is 2, and then it's cubed, so we've got 2 cubed. This 64, cube root will be 4, and then it's squared, but 4 is 2 squared. So we've got 2 cubed multiplied by 2 squared, squared. But 2 squared squared, multiply these to get 4, that's 2 cubed times 2 to the 4, and then we add the powers because we're multiplying, that will be 2 to the power of 7. So on this side, this A must be 7. This question here was really just a surds question. 72 to the power of a half is the square root of 72. So you're just looking for square numbers that go into it. 9 goes in, it has a square root of 3, and then for the 8, 4 goes into 8, which has a square root of 2. So you get 3 times 2 is 6, multiplied by root 2. The question asked to find the value of the letters, so you need to make sure that you didn't leave the final answer as 6 root 2, but actually say clearly that 6 is C and D is 2. This one here, hopefully you spotted square root of 100 is 10 and cube root of 1000 is 10. So this term was 10 cubed, this term was 10 squared, giving us 10 to the B. Add the powers and you get B is 5. This one was a bit harder. So the power of minus a half, the negative makes you reciprocate and the half is square root, but we want it as a power of 3. So 1 over root 9, well, root 9 is 3, so that's really just 1 over 3, or 3 to the minus 1. Here, cube root of 27 is 3, and then it's squared. When you look at it like that, it's a lot easier. So you see 3 to the minus 1 multiplied by 3 squared. You would add those powers to end up with this expression here, and it wants the expression as e plus 2, so given that you would add the powers, the e must be minus 1. And this final one, writing it in terms of root 2, we've got the square root of 8 cubed. Square root of 8 is 2 root 2 by simplifying the surds, and then it's cubed. So 2 root 2 times 2 root 2 times 2 root 2, the 2 cubed is 8, and root 2 cubed is root 2 times root 2, which is 2, times another root 2. So you end up with 16 root 2, so F is 16. Pause the video, have a go at these questions. So let's have a look. 3 times 4 is 12, that bit's correct, but it should be 12 multiplied by 10 to the power of 5. Not sure where they got that 20 there from. But 12 times 10 to the power of 5, that's not in standard form. We'd need to make it 1.2, so it's a single digit before the decimal. Now, 1.2 times 10 would make 12, and then times 10 to the 5. So overall, 10 times 10 to the 5 would give us 10 to the 6. Similar sort of thing here. 8 divided by 2 is 4, but then this power of 10 shouldn't be divided by anything. So it should have just been 4 times 10 to the power of 10. This one here, 7 multiplied by 6 is 42. 10 to the power of 4 times 10 to the power of 3 is 10 to the power of 7. So this calculation is correct, but we just need to put it into standard form. So 42 would be 4.2 times 10, and then multiplied by another 10 to the 7. So we end up with 4.2 times 10 to the power of 8. Now what I've done there, you need to watch out that when you write your powers, they are clearly sort of smaller and up in the air compared to your number. Otherwise it could look a bit like 108. Okay, let's look at another one. So we're adding 3 times 10 to the 4, add 2 times 10 to the 5. Let's just think what that means for a moment. So 3 times 10 to the 4 is 30,000. 2 times 10 to the 5 is 200,000. So actually, if we add them up, we get 230,000, which is 2.3 times 10 to the 5. This one here, 8.4 divided by 2 is 4.2, and 10 to the 6 divided by 10 to the 3, we're not going to do 6 divided by 3. Remember rules of indices. 10 to the 6 divided by 10 to the 3, we need to subtract those powers. 6 minus 3 is 3. So the only thing wrong with that one was that power should have been a 3 there, because 6 minus 3 is 3. And finally here, 10 to the 0, remember that's just 1, so 6 times 4 is 24, but it's said to give the answer in standard form, so that's 2.4 times 10. Have a go at these questions. Pause the video. So 1,000,000 times bigger than 9 times 10 to the 7, if we were to just multiply that by 1,000,000, well, 1,000,000 is 10 to the power of 6. So if we multiply this by 10 to the power of 6, we would add on the powers. 7 add 6 is 13. So we would end up with 9 times 10 to the power of 13. 1,000,000 times smaller, same idea. If we divide by 10 to the power of 6, we would subtract the powers, and we would end up with 9 times 10. What number is 1,000,000 greater than 9 times 10 to the 7? Now you need to be a bit careful here. 9 times 10 to the 7, well, that's 90 million. It's a 9 followed by 7 zeros. So 90 million add 1 million would be 91 million. So that's 9.1 times 10 to the power of 7. 1,000,000 smaller than that, so if you've got 90 million and you take away 1,000,000, you would have 89 million, which is 8.9 times 10 to the power of 7. This calculation here, 4 times 10 to the minus 2 plus 5 times 10 to the minus 3. Well, that's 4 over 100 plus 5 over 1,000. Now, if we're adding things with different denominators, that's complicated. What we should do, if we multiply top and bottom by 10 on this fraction, we'll get 40 thousandths plus 5 thousandths, which makes 45 thousandths. And then if we divide top and bottom by 5, we'll end up with 9 200ths, which is what we were asked for. Last couple of questions then. 3.16 times 4, well, 3 4s would be 12, and 16 4s are 64, so that's going to give us 12.64. And then we've got 10 to the 4 multiplied by 10 to the minus 2. So we add the powers. 4 add minus 2 is 2. So we've got 12.64 times 10 squared, but that's not in standard form. We only want one digit before the point, so that's 1.264. And that would be multiplied by 10 to make this number, and then by another 10 squared, so altogether that's multiplied by 10 cubed. 3.16 divided by 4, well, 3 divided by 4 is 0.75, 0.16 divided by 4 is 0.04, so I think that's 0.79. And then we've got 10 to the 4 divided by 10 to the minus 2. We need to be careful here. We've got 4 minus minus 2, which is 4 plus 2, which is 6. Again, that's not in standard form, so if we rewrite that as 7.9, and then we would need to times that by 10 to the 6, but also this needs to be divided by 10 to make the number we actually wanted. So if we divide 10 to the 6 by 10, we'll get 10 to the power of 5. And finally, pause the video and have a go at this question. Make sure you remember to put your answer into standard form and round it to 3 significant figures. And don't forget the units. So we've got 1.989 divided by 5.792. You can do that on your calculator and get 0.343 to 3 significant figures. Looking at the powers, 10 to the power of 30 divided by 10 to the power of 24. We subtract the powers to end up with 10 to the power of 6, and that means we've got 0.343 times 10 to the power of 6. But we want to write that as 3 before the decimal point and then the rest of the digits, so 3.43. But this number is 10 times smaller than this one, so we need to make it 10 times smaller. So instead of 10 to the 6, we write 10 to the 5, and then the units were kilograms for both of these objects. So the final answer, 3.43 times 10 to the power of 5 kilograms.